So let's look at what are we going to do today. We'll look at what is big data. We'll understand what are the limitations of the existing solutions. Why do we need something like Hadoop? Okay, we'll also understand how does Hadoop solve the problem. Then we will be we'll be looking at we'll be introducing you to Hadoop. We'll look at the various components of the Hadoop ecosystem. We'll also look at the core components of Hadoop, which is HDFS and MapReduce. We'll go into details of HDFS architecture. We will also understand how does the MapReduce job execution work. We'll understand terms like rack awareness. We'll also understand how does a file read and write happen in Hadoop. And then we'll also take a sneak peek on the Hadoop 2.0 architecture. Okay. We'll try to understand where MapReduce is used. Okay, what were the traditional ways of solving problems which MapReduce is solving today in earlier days. Okay, we'll also understand how does a MapReduce program look like. We'll do at least 4 Java programs today. Okay, we'll show you 4 Java programs today at least. Okay, we will also discuss a little bit about Hadoop streaming. Okay, which is a way to actually run Java, run code without run MapReduce code without Java. Okay, so we'll discuss a little bit. We'll not go into the detail here. We'll understand the concept of combiner and partitioner, obviously other than the map and reduce. We'll also understand the data flow. We'll understand how the input splits are done, and then some of the input-output formats. Okay, so these are the topics we're going to cover today. Okay, so let's get started, guys. Okay, so what is big data? Now, I'm sure everyone has heard about big data. Everyone has done their own research on big data till now, and they know what is referred as big data. But let me also tell you what big data is according to me. Now, not very different than what you've thought. It's lots and lots of data. That's what it's called. That's why it's called big. Now, it is not in megabytes or gigabytes when the data reaches terabytes and petabytes. And if the data is really large and complex in the sense that it is not not just structured data, a lot of unstructured and semi-structured data is called big data. And there are a few definitions associated with big data where they say that, okay, big data, when you have large amount of data flowing in your system, okay, at a big speed and a big variety of data like big streams from, like if you click on something on say a like or a share on Facebook, that contributes to big data. Large amount of videos, audios which are shared is big data. The amount of data which is the kind of data which is shared in say I mean the amount of data, the customer data which you get, the kind of customer behavior data which you get in large organizations, that contributes to big data. Why are people so crazy about big data these days? What does big data help in? So yes, so this is basically the motivation about, see, everyone had a lot of data. It's not that data has come today, but there was not many ways of analyzing that data. Okay, so with tools like Hadoop coming in, it has become much more easier to analyze that data. Okay, and you can do predictive analysis, you can do trend analysis, you can look at customer behavior, you can run specific campaigns for customers, you can do say a fraud analysis using big data. So lot of domains are finding applications there. It's all started with social media, but now, I mean, right from banks to retail, we will be looking at some examples to government. Everywhere people have started realizing the power of big data analytics, and they are doing analytics there. Okay, so now there is an example here which says New York Stock Exchange generates about 1 terabyte of new trade data per day. So what is big data? Now the first question which comes to us is, why are we here and what is big data? Can someone tell me, I mean, what does Facebook has to do with big data? Facebook wants to make sure that I mean, as advertisers, right? Edureka also advertises on Facebook. So as advertisers, we want to make sure that the ads reach the right people, right? So that targeting is done based on that. So all preferences which you have, you must be seeing that if you visit a site, after that you see the ads of that site all for a long time, right? So all that is done by managing that big data only. Okay, is that fine, guys? So that's basically a little bit about big data. We'll understand more about it. Now we have a picture on the right. Can anyone tell me why have we put an aeroplane here on the right? Okay, so Vinayak has given me the right answer. Vinayak tells me that system logs in black box. Okay, so everyone knows what is a black box in a airplane. Okay, so basically see, a black box is a part in an aeroplane where it will be recording everything which is happening. Okay, whether it is flight information there, whatever system changes are happening in your speed, and everything will be noted down. You don't, it stores huge amount of data in terabytes, not something which will be used every day, but in case of any eventuality, if there is an accident or a crash, then that is the only part which will be looked at, and they'll try to do analysis that what happened and how to avoid that in future. Okay, so that's also huge amount of unstructured data. Okay, so then we have this electricity thing here, grid here. Now again, here in the electricity grid also there is huge amount of I mean, you must have heard people in India suffer that a lot. Abhishek is probably not prone to that as much, and he's immune to that. But then people in India have to face these power failures. I might be teaching you in another hour in a completely situation where it is there's no power, but hopefully so basically you have to, there's a lot of data here as well. I mean, all the nodes, where substation, which grid point, where the electricity is being routed, okay, where is the consumption. So all that huge amount of data, right, is something which is there, which we have to analyze. If we analyze that properly, we'll be able to probably route things properly. Some people from Karnataka and Tamil Nadu here in India will be knowing, right, the fight which is happening all the time, right? If we could use a good level of analytics, probably a lot of things could be saved there. So that's where in the real life a big data analytics is going to help. And the reason I have put all these examples here is because you will be seeing in utilities, you will be in say utilities, you will be using big data analytics. Now the Aadhaar scheme which is there in, does everyone know about Aadhaar in India? That also uses Hadoop. Okay, so Abhishek, Aadhaar is like a social security number thing here, which has been started in India with a special biometric card. Okay, so it's like a SSN for you. So there also all the citizens are being mapped, and I mean, I'm sure everyone else has looked at it, and so there also we use Hadoop. Okay, so you'll be seeing going forward there are a lot of places where Hadoop will be used. It is just coming up now, and then in the next few years you'll see everywhere this application will be coming in. Okay, so now on the right hand side I've put this files here. Can someone tell me why is this here? Now yes, it is unstructured data, it is physical data, and government office files is what Rahul tells me, right? So these government office files have to be, if you could actually get them into Hadoop, a lot of things would have been solved. So now we understand, I mean, a little bit understanding is there that what is so now do we know the difference between unstructured and structured data? Can anyone answer that? That's very important to understand here. So what is structured and what is unstructured? Can someone answer that question? I'll obviously tell you that. Okay, so Abhishek tells me, okay, Abhishek tells me that structure is tables and columns, right? Vijay, who is I really like your answers, Vijay. Vijay is telling the difference is un. Okay, the good question, good answer. So structured is in tables. Structured could be in tabular format, columns and rows, right? And Vijay also tells me, now Vijay has gone a little deep. He tells me schema. So yes, a fixed schema is something which, or a schema is something which is a characteristic of a structured data, right? Very nice. This unstructured data is something which has been growing a lot in the past few years. Okay, in the past few years we've seen that lot of unstructured data is being dumped by, it started with social media companies. Now almost all the companies are actually getting there, and the challenge is to analyze that. Okay, and it is growing really fast. We'll see in the next few slides how does that grow. So now if we go forward, so this is a Facebook example where we see that, okay, there's so many people on Facebook. I can't even read this. It is probably 500 million active Facebook users, okay, in 2011. So I'm sure it will be 1 billion by now. There's so many, so 1 out of every 13 people on earth, I'm sure this is an old one, so there will be many more people. The idea is to actually give you a view on not exactly these numbers, but just to show you that the huge amount of data which is being dumped every day. So these many links are shared every day, these many friend invites, you tag photos, status updates. Facebook has to actually do analysis of everything here, okay? And it becomes very, very difficult. We'll see what are the challenges just in a while. But here in this slide, I just want to show you that, okay, this is the kind of data we are talking about, okay? Few years back, this was not the case. No one was actually analyzing this data. Now, there are a lot of manufacturing companies in India who will be getting this amount of data, but they will not be able to analyze it, okay? And therein lies the opportunity, okay? There will be a lot of utility companies, the oil companies, the electricity companies who also have that data, but then analyzing that data is the challenge which every company is facing. And that's why we are having this class today, right? So you get a feel of what is Facebook up to, right? If we go ahead, let's see another example and see what is now Twitter again, right? Again, a social media company. So Twitter has what? Twitter has 500 million registered users, okay? So in USA, and I'm not a big fan of these stats, but then I mean these have been taken from some blogs. The whole idea, the crux of the matter here is that a lot of people are there, a lot of activities happening, and one very important thing here, why we are doing all this analytics is 79% of US Twitter users are more likely to recommend brands they follow, okay? And 67% of US Twitter users are more likely to buy from brands they follow, okay? So that's the idea, and that is why this is so much important. It's not just sheer fun. Facebook or Twitter, now they're serious business ways. I mean, I'm sure a lot of you guys must be using Twitter and Facebook as their marketing, as the companies must be using as their marketing engines, right? So basically, and they need to do a lot of analytics. They need to understand which users to target, whom to target, what time of the day to target. So all that analytics, say for example, if I run an ad at 4 p.m. in the afternoon in India time, most of the people in India will be working at that time because that is the time when everyone works, right? Sure, Vijay, I think it is Edureka. You can use that, and then so now a lot of people, but if you target an ad at say for example 6 o'clock in the evening, okay, a lot of people will be traveling, so they may not be on their systems, and that may not be a good time. So when is a good time, which is a good time, what type of audience are available at what time, all this is the analytics which we want to do with the data which we have, right? Is that clear, guys? Does that make sense? And is this something which you've understood properly? Can I quickly get a round of smileys if everyone has understood it? Or if you have any questions, I can quickly answer them as well here. Great, Vikas. Thank you very much. Great. Thanks, Anup. Okay. So I understand everyone has got the idea. Two things which I wanted to make clear from last few slides was that one, the rise of unstructured data, the difference between structured and unstructured data, the kind of industries where it is applicable and where it is happening, the dumping of the data, okay, and some examples of the companies which are actually doing big data analytics and they are successful, okay. So Facebook and Twitter are two such companies, right? So if that is something which you've understood, that is all I wanted to convey from these foils, okay. The numbers, exact number, it is 79% or 67%, that is for I don't know which exam will ask you. If they ask you, don't answer that question, you can ignore it, tell them that I don't want to answer that, if you've got the idea, right? Okay, so okay, very good question. Is Hadoop only for unstructured data? Does it also work on structured data? Is what Abhishek has asked me. Now, Abhishek, for unstructured data, largely Hadoop is used and HDFS is used. There's something called HBase in Hadoop. We will come to that later. We do analytics on structured data as well. Going forward, there will be a time when all type of data could be analyzed using Hadoop. It started for unstructured data. Okay, is that clear, everyone, and Abhishek? Great. So the whole idea is if we can distribute things, okay, and I'll tell you why it is required in just a short while, okay. Great, Shyam. Thank you very much. Okay, now let's move ahead. Everyone knows Instagram. Is there someone who doesn't know Instagram? Okay, so Instagram, I mean, Instagram again is one of the big successes of the social media time, and I mean it's a app, it's an app which takes pictures, and the difference is just can someone tell me what is the difference between, say, a Facebook picture click and share, and between Instagram picture click and share? Anyone who knows that, who's been using Instagram? While others can read through this slide and see Instagram gains one new user every second. Okay, Instagram was sold to Facebook probably for $1 billion. Right. So Vinayak tells me it has image filters. Right. So something which you could do in Photoshop earlier, I mean, some of that part can add effects in Instagram. Right. So that was just a small innovation which Instagram did, and it became an instant hit on internet. Okay. So that's, and then so 1 billion photos have been taken with Instagram. So you can imagine the kind of data which Instagram has to handle, and with all those effects and filters, it becomes huge, right? So that's again one company which will be using a lot of big data analytics. Okay, and there are many more such companies. We'll come to that as well. We'll know. I'll also tell you a link from where you can go and read what all companies are using Hadoop and what do they do with Hadoop. What is their cluster size? All that information is also available in public domain. Okay. Now there's one slide which actually tells you about that. There's AOL, there's eBay. They use for different reasons. I mean, I want you to actually go through this. I'll share a link with you. Facebook, for example, let's talk about Facebook. Okay, Facebook uses Hadoop to store copies of data. Okay, and they do machine learning as well. So I'll tell you a little bit about machine learning in just a while, but not in detail. Now it has a 1100 machine cluster with these many cores, right? So each commodity node, what is commodity is something which you should think about right now. I'll tell you just in a while. Okay, so they use 8 core and 12 TB of storage on each machine. Okay, so this is a typical data node in I'm using the term data node. I'm just using the liberty of using the term data node. I'll explain that in a while. Okay, so has 8 cores and 12 TB of storage. Okay, this is the storage capacity of each node there in the cluster. It has a 300 machine cluster with this kind of thing, right? So basically, and then we have eBay, which has a 532 node cluster. Okay, heavy use of Java MapReduce. So MapReduce is the programming model there, pig, hive, HBase. All these tools, guys, we'll learn in this course. Okay, so if you understand this well, you'll surely have options to moving into any of these companies. Now eBay uses for search optimization and research. Okay, now on eBay, if you go to eBay and if you look for some product, okay, there'll be thousands and lakhs of products there, different search. You should be able to search them on various terms. So that is where Hadoop is used there. Okay, let's move ahead. Anyone has a question here, and shall I move ahead if this is clear? Quickly, can you quickly say yes or no? Okay, Anup tells me yes. If no, I mean, it's okay if you don't write. I'll assume that we can move ahead. Okay. Don't let you type. Sometimes I'll force you to type so that you are not sleeping. Okay, just to make sure that you're not sleeping. Okay. Okay, now we have this data volume growing exponentially. Now, what does this mean? Okay, now we've been talking about a lot of companies till now. Now this is one infographic. It has been taken from EMC here, which shows the amount of data which is growing. Now 1 terabyte is here. Okay, so this is 1 terabyte of data. What we're talking about are zettabytes of data. Okay, which is 1 billion terabytes. Now some estimates said that to 1.8 zettabyte will be there. These are again old slides. So I mean, the whole idea is not to know these exact numbers, but to understand the amount of data which we're talking about, and this is very important. The world's information doubles every 2 years. Okay, in the next 10 years, this is the opportunity. So this is where the opportunity lies. Now all of us who are working in this big data domain, and a lot of you will be working on that going forward, whether you like it or not, most of the people here in India as well as in the US will be working with big data in some form or the other in the next 5 to 6 years. Okay, so you guys could be early adopters there. And and the reason why I've put this foil here again is to tell you that this is how it's going to grow, and everyone will be a part of this revolution, big data analytics. will be a part of it, whether you like or you don't like it. So it's better to actually understand things now and be early adopters there of this technology. Okay, great. So yeah, so Narayan has told me yes, sure, and I think I lost the chat window. No one has said yes. Okay, sorry. Okay, so guys, so this anyone has a question here, or I'll move ahead. So basically, till this time, I'll just rephrase and I'll make sure that everyone understands. We talked about unstructured data, right? We talked about the different companies which may be using the unstructured data. Then we also talked about some of the companies which actually became very successful using big data analytics. Okay, and we also showed you how the data volume is growing now. There's another infographic, and after that we'll move on to why Hadoop. Okay, this is important again. I mean, okay, now Vikas is asking me a question. Can we can use Hadoop for structured data as well? Well, because the same question was asked just a while back by Abhishek. Yes, you can. Yes, you can. There are some limitations, but you can. Okay, and we will. HBase is the component of Hadoop which is used to store structured data. Okay, now that's not really completely like your relational database. It's a different kind of database. We will be talking about it when we reach HBase. But yes, that's true. You can use it. Okay. And as we go ahead in a year or two, you will see that there will be provisions where you can completely replace your MySQL with a Hadoop kind of thing. People are working on that. Okay. Now this graphic shows you how the overlap has happened between structured and unstructured data. So in the times of when Shah Rukh Khan came in or Maine Pyar Kiya came in 90s, there was no unstructured data. Okay. It's only after that unstructured data grew. And the age of Ranbir Kapoor, this is the situation. Okay, so now and relational databases are, I mean, relational data or a structured data see, the fact is that this data is also growing, but the speed at which this data is growing is something which is phenomenal, and that is where the challenge is, and that is where the opportunity is. Okay. So let's move ahead if everyone is fine here, and let's see a few more things. We'll do a small exercise also now. Okay, so now we've seen that huge amount of data is being stored. Okay, now the challenge probably, I mean, is not the storage. You have storage capacities have scaled up beautifully, right? The challenge is something else, and let's try to see what that something else is. If you've seen this presentation earlier, then probably this is a very easy question to answer. But still, I want everyone of you to actually answer this. We have this one machine here which has 4 I/O channels. Each channel can run 100, do 100 Mbps of input and output. How much time will it take to do a 1 terabyte of transfer? Can someone tell me that? Can everyone tell me that? I'll give you say 30-40 seconds to calculate that. Okay. Abhishek has given me an answer. Okay, Vinayak has given me an answer. Tell me, okay, guys, when you write this answer, also tell me if you've seen this earlier or not. Okay. If you're calculating here, okay, everyone is giving me good right answers. The first time, I'll tell you guys, for the first time when I showed this thing, okay, no one actually answered this question right. The few people did, and you'll also have to tell me how did you calculate this. So I want answer from everyone. Anup, Vikas, everyone has to answer this. Okay. And do not worry if the answer is wrong. Okay, it doesn't really matter. And that's not the purpose of doing this exercise, whether to get the right answer or not. Okay. The purpose is for you to actually calculate and understand. Okay. Abhishek has given me a big calculation. Abhishek, it must be right only. If you've done such a big calculation like a old professor, I'll say, yeah, you have done it right. So like the time in college, right, we used to fill in a lot of things so that the professor thinks that this guy knows something. So we'll give him some marks. I'll give you marks like that. Okay. Everyone else, are you guys calculating it? You want some time to calculate it? Okay. So I'm still waiting for answers from Rahul. Shyam, Rahul has given me, great. Okay, no problem. Sure. Thanks. Rahul has given me an answer. Shyam has given me an answer. Dayanand, are you with me? Vijay has given me an answer. Vijay always comes with, Vijay, what is that? 400/4000. Say, give me answer in minutes here. I'm bad at calculation. I'm very bad at maths. I'm not. I'm actually decent in maths. A lot of other subjects I'm very bad at. Okay. Okay. Dayanand, are you calculating? Yeah. Vijay, you can use a calculator, man. If you, I will not use a calculator in front of you. Guys, you can always use Google for answering, okay, if I ask questions. And the reason why I tell you that is because it's not only from here which you're learning. You can, if you Google things, you'll probably get a lot of other perspectives as well. So Prahlad has given me some answer which reads into 10737418 seconds approximately. Prahlad, uh, looks like something which has gone above my head. Okay, but never mind. Uh, just important thing is to understand that it takes a lot of time. Okay, Shyam has given me the right answer. Shyam has told me how to calculate that, and thank you very much, Shyam. Shyam tells me 1024 into 1024 divided by 100 divide into 4 and divide by 60 is the answer in minutes. Yes, that's right. So Dayanand, are you there? Are you actually calculating it? Okay, great. So see, the answer is 1 terabyte. So 1024 into 1024 MB is 100 MBs per second what it is able to do. So 1 terabyte will be 1024 into 1024 MB divided by 100, also divide by 4 because there are 4 IO channels. You can do 4 reads in parallel, and then divide by 60 as Shyam has rightly said and a lot of other people have said. So it approximately takes around 45 minutes to do that. Okay, right? So now the whole idea is not to actually make you calculate this, but the idea is to show you that for 1 terabyte of data, okay, it is taking so much time to actually read it. Now what do you have to do in real time, real life? All this data is dumped somewhere. If you have to read it back, you have to read it back multiple times, right, to do analytics, right? Is that right, guys? Yes or no? Is this making sense? Yeah. So if you have, if it takes for 1 terabyte it takes so much time. When we talk about zettabytes of data, think of it this way: if Facebook had to read it in this manner, what analytics would they be able to do? Every day they have 500 terabytes of data, and that is old estimate. Okay, so a traditional way of doing things like this, vertically scaling things. Vertically scaling thing means, for the people who don't understand this jargon, I really don't like these jargons. Vertically scaling means that you improve the system, put a better machine, improve storage in a system. So vertical scale is not going to help. Put more expensive machine. Okay, that's not going to help much. Is that clear, everyone? So the solution to that is something like this. So if, imagine if we could do the same thing, if we could partition that data and put it into 10 different systems, how much time will it take? Now I want this answer in 10 seconds. Everyone has to answer. Vijay, you don't need maths here, man. Okay, so now everyone has given me the right answer except Vijay. Vijay is not answering. Okay, I'm saying if we had 10 machines here, okay, if you partition this data and put it into 10 machines, how much time will it take to read that complete data? Yes. So yes, the right answer is yes. If we could do it, if we could actually do it, yeah, 45 by 10 is the right answer. Now that's a very, very simplistic view of saying things. This could be one solution. Now vertical scaling is not going to help, that is clear, right? We understood. Even if I add say 10 channels here, not possible. The maximum speed of SATA 2, which is the hard disk standard, is how much? Like 500, I believe it is 500 MB per second, or SATA can read it in, I believe SATA 2 can do it in 500 GB per second, and that's gigabits. Okay, so that's not, those things are not going to help much. Okay, you cannot go 10 times there. So probably a good solution and a solution could be horizontal scaling, which means add more machines. If you can partition this data, do it in a distributed way. So now around 10, 15, 20 years back, there was a time when this grid computing or distributed computing or parallel computing was very much in thing. Okay, and there was so there is a difference between grid computing and what we do here, right? Okay, so that time the challenge was CPU speeds. So you wanted to distribute the compute. If you have a big equation to solve, which you cannot solve in one machine, you distribute it across clusters of computers and let those clusters actually solve that and give it back to you, right? This is what we used to do earlier. Okay, when we, but is everyone in sync with whatever I said now? Quickly a smiley if everyone has understood. Okay, S is also fine. If someone has not got it, please tell me.